Hey there and welcome. So, you've launched a new ad, or maybe you're trying a new product feature. You think it's working, but how can you be sure? Today, we're diving into hypothesis testing. This is the toolkit for separating what's real from what's just random luck, and it's how we turn our gut feelings into a solid, data-backed verdict.
So here's how we're going to tackle this. We'll start by putting a simple business question on trial. Then we'll hear from the two competing sides of the story. We'll bring in our star witness, the p-value, and talk about the risk of getting the verdict wrong. After that, we'll walk through a real-life case study. And finally, we'll see how this all leads to a powerful, data-driven decision. Let's get into it.
All right, first up. Look, we're always trying new things, right? We're hoping they'll move the needle. But you know what they say? Hope is not a strategy. To get real answers, we've got to stop just asking questions and start putting them on trial.
Let's start with a classic scenario. Your company just rolled out this big, flashy new ad campaign. You look at the numbers, and hey, sales are up. Everyone's high-fiving. But then the big question hits. Was it really because of our ad?
I mean, maybe it was just a good week. Maybe a competitor had a bad week. Maybe sales would have gone up anyway. And that right there, that's the core challenge. Figuring out if you're looking at a real effect or just the random ups and downs of the market. And this is exactly where hypothesis testing comes in. You can seriously think of it like a courtroom for your data. It's a structured, scientific process that helps us decide with some level of confidence whether the thing we saw was a real change or if it could have just been a fluke. Okay, so just like in any good courtroom drama, every single hypothesis test starts with two opposing sides. You've got two completely different stories about what's actually happening with the data. On one side, we have what's called the null hypothesis, or H0. This is basically the skeptic in the room. It's our presumption of innocence. It assumes nothing happened, no effect, no difference, the ad did nothing. Then on the other side, you've got the alternative hypothesis, H1. This is the prosecution's case. This is the new idea, the claim that there is a real effect, that our ad actually worked. Let's make this super practical. Imagine our question is, does this new diet actually help people lose weight? Well, the null hypothesis, our default assumption, is that nope, no weight loss occurs. It has no effect. The alternative hypothesis, the thing we're trying to prove, is that yes, weight loss does occur. Our job now is to gather enough evidence to see if we can confidently reject that presumption of innocence. So you've got these two competing stories. How in the world does the court decide which one is more believable? Well, it calls in its star witness. And in the world of statistics, that star witness is something called the p-value.
Okay, the p-value can feel a little weird at first, but stick with me. It answers a really specific question. It asks, if we assume the null hypothesis is true, that our ad did absolutely nothing, what's the chance we would get the sales numbers we got, just by random luck? So if your p-value is super small, it means your results are really surprising, a huge coincidence, and it makes you start to doubt that whole presumption of innocence thing.
But how small is small enough to be convincing? For that, we need a line in the sand. And in most fields, that line is drawn at 0.05. It's what we call the significance level. You can think of it as the statistical version of beyond a reasonable doubt. And that brings us to a really simple rule for our verdict. If the p-value from our test is less than that 0.05 line in the sand, we say the result is statistically significant. The evidence is strong enough and we can reject the null hypothesis. But if the p-value is bigger than 0.05, we just don't have enough evidence, so we fail to reject the null. And notice that language. We don't accept it, we just say we couldn't prove it wrong this time. Now, here's something that's absolutely crucial to remember. Our verdict is always based on probability, never on 100% certainty. And just like in a real court, there's always a risk of making the wrong call. I mean, just think about that for a second. The weight of it. Imagine a justice system makes a mistake and convicts someone who is actually innocent. It's a terrible, devastating kind of error. Well, in statistics, that's a type 1 error, a false positive. It's when we reject the null hypothesis. We say it works, when in reality it didn't. The flip side of that coin is a type 2 error, or a false negative. That's like letting a guilty person walk free. We fail to find an effect that was actually there. So you see, we're always trying to find the right balance between these two potential mistakes. Okay, theory time is over. Let's put all these pieces together and see how this actually works in a real-world scenario. Let's imagine a school wants to know if a new teaching method is truly better than their old one. It's time to put it on trial. So let's follow the trial. Step 1, the claim. The new teaching method boosts student scores. Step 2, the data. They run a test, and the old method group scored an average of 70, while the new method group got a 75. Okay, interesting. Step 3, the test. They run what's called a t-test to compare those two averages. And step 4, the evidence. The test spits out a p-value of 0.03. So, what's the verdict? Well, since 0.03 is less than our 0.05 line in the sand, we reject the null hypothesis. The evidence is statistically significant. It looks like the new method really does work.
So we reached a verdict in our school case study, which is great, but the real power here isn't just about one trial. It's about taking this whole way of thinking and applying it everywhere.
And I mean everywhere. This isn't just some abstract thing for scientists. Marketers live and breathe this stuff with A/B testing ads and websites. In healthcare, it's how we know if a new drug is actually effective. It's used in manufacturing for quality control, in finance to spot fraud. This framework is literally the engine behind almost every data-driven improvement you see out there.
And that's really the big idea I want you to walk away with. Hypothesis testing is the bridge that takes us from a pile of data and a hunch to actual, credible evidence. It is the absolute heart of making smart decisions with data instead of just guessing.
So I'll just leave you with this one final thought to chew on. In your own work, or even just in your own life, what's one assumption you've been running on that you could actually put on trial with data? Think about it. Thanks so much for joining me.